Alright, I have some review problems. They're worked out for you. I've actually worked almost every problem in the review. So some of them you might want to pause and write down as we go. The number one problem is e to the second times e to the fifth. When you have multiplication and you have two bases, you add the exponents, so 2 plus 5 is 7, so e to the seventh is that answer. For number 2, you have an exponent outside the parentheses that has to be distributed to both of the inside parts. So 2 is now to the negative 1 power, and e is to the positive 2x power. And so 2 to the negative 1 means it's going to be moved to the denominator, so your answer is e to the 2x divided by 2. For number 3, I've taken the square root of 16e to the 10th, and I've rewritten it as 16e to the 10th to the 1/2 power, because the 1/2 power represents the square root. The square root is equal to an exponent of 1/2. Now if you distribute the 1/2 power to both, that's the 16 to the 1/2 power, well that's the square root of 16, which is 4, and then e is to the 10th power times 1/2, and 10 times 1/2 is just 5. For number 4, you have log base 5 of 25, so I'm going to start out by making it equal to x, basically for myself. Let me write that again in a different color. So I write 5 to the x equals 25, because that's just rewriting it. And then I determine what x equals, because 5 to what power equals 25, and that's going to be 2. For number 5, however, a lot of people have really struggled with this, so I want to kind of explain it out in a little bit better fashion. I'm still going to have it equal to x, so that gives me 1/3 to the x power equals 81, because I'm rewriting it. And then I have to determine what that's going to be. Well, first of all, what I did was I said, this is a fraction. If I want to make it into a whole number, I can do that. If I flip 1/3 and make it 3, all I have to do is put a negative on the x, because remember, the negative stands for the reciprocal. Once I do that, it's a lot easier to see what's going to happen here, because I have 3 to the negative x equals 81, which is actually 3 to the 4th power. Then you can see, well, if it's 3 to the negative x and 3 to the 4th, then negative x has to equal 4, so x equals negative 4 is my solution. And hopefully that makes a little bit more sense if you've really struggled with what to do with the fractions. For number 6, log base 2 of 1 equals x. 2 to the x equals 1. There is only one exponent in the whole world that makes 2 become 1, and that is 0. Alright, number 7, we are expanding this problem. I've gone ahead and separated the easy part, because it's 2 times x to the 3rd divided by 4 divided by y. So 2, the times became plus, divided by became minus, divided by became minus. So I just split them up that way. Now, the next thing you have to look for is, are there any exponents? Is there an exponent that has to be moved? And there is. There's a 3 right there. So when I work that out, I'm going to have log 2 plus 3 log x minus log 4 minus log y. Okay? Now look, I didn't put that little 5 in there yet, because sometimes that can be confusing or get in the way. So now I'm just going to go back, and next to my g, I'm going to put my little base 5, because if it starts as base 5, then it has to end as base 5. So that is your expanded answer. For ln of 16x squared, it's 16 times x squared. The times becomes plus. Now I'm going to move this exponent to the front, which will make me have ln 16 plus 2 ln x. And luckily, with ln, you don't have to worry about what the base is. Number 9 is another ln problem, so I've split this up already. 4 times x squared times y to the 5th. So ln 4 plus ln x squared plus ln y to the 5th. but I have two exponents that are going to have to be moved. So I'm going to rewrite that as ln 4 plus 2 ln x plus 5 ln y, and that's fully expanded. Number 10, now we're condensing this. We're trying to bring it back. So the very first thing you have to look for when you're condensing is a coefficient. If I have a coefficient, it's going to move over here to become the power. So I've moved the 3 to be the power, so it's 4x to the third power. Now what does addition become? Addition becomes multiplication. Now I'm down to 1 logarithm, and I'm going to keep the base. Let me switch back to the smaller font here. The one thing that you have to do here is just simplify it. So I'm going to do this right here. So I have 2x times 4 to the third power, which is 64, x to the third power, which is x cubed. And I'm out of space, but hopefully you can see this okay. 2x times 64x to the third, 2 times 64 is 128. X times x cubed is x to the fourth. That's your solution right down there. For number 11, we are again condensing this. The first thing I did was I took this 2 right here and I moved it to the power. So now my 2y's to the second power. Once you do that, it's not so bad because subtraction becomes, let me write that again. Subtraction becomes division. So ln, so I take the 72x divided by the 2y to the second power. Since the squared is for the 2 and the y, I am going to rewrite this as 72x over 4y squared. And you can go the extra step and say 72 divided by 4 actually turns out to be 18. So 18 goes on the top with the x, and y squared stays in the denominator. Number 12, we're going to be solving. So all I'm going to do is rewrite this. 2 to the fourth power equals x plus 8. 2 to the fourth power is 16. Subtract 8 on both sides, and I get x equals 8. That one's pretty easy. Number 13, the first thing I have to do is condense this into 1 logarithm. So I have x times x plus 9, and you're probably thinking, where did this 9 come from? Well, if you're looking at your review, I had to change it because it wasn't working out right. So you need to change and make this number right here a 9. Once you change it, though, we get log base 6, x times x plus 9, we're going to distribute. Now we have a logarithm, so I'm going to use 6 to the second power equals x squared plus 9. 6 to the second power equals x squared plus 9x, I meant to say earlier. So 36 equals x squared plus 9x. I'm totally out of space. So I'm going to go ahead and subtract the 36 to the other side and make this be 0 equals x squared plus 9x minus 36. And then I need to factor that x squared plus 9x minus 36. And I don't have space on my next page, so I'm going to erase a little bit over here so that I can work that out for you. Alright, so if I have 0 equals x squared plus 9x minus 36, factoring that out, you can do x minus 12 and x plus 3, because negative 12 times 3 is 36, negative 12 plus 3 is, I have them backwards, should be plus 12 and minus 3, plus 12, minus 3. So my solutions are negative 12 and positive 3. And actually, in case you're curious, negative 12 is an extraneous solution. Number 14, e to the x is 5. How do we get rid of e? We use ln because they are inverses. So you ln both sides. Ln cancels the e and leaves an x. X equals ln of 5. You're going to do that in your calculator. Do math log ln of 5, and you get 1.609. Number 15, I've worked mostly out already. The first thing you have to do is subtract the 9 from both sides because we need the 2 to the 3x to be isolated. So now we have 2 to the 3x equals 16. Then to get rid of the 2, we do log base 2 on both sides. So here's where we are now. The log base 2, try that again. The log base 2 of 2 cancels, leaves me with 3x. Log base 2 of 16 is log 16 divided by log 2. So 3x actually equals 4 when you do this in the calculator. Divide by 3 and x is going to be 4/3. Number 16, the first thing you have to do is divide by 9 to get the ln by itself. Then you take the ln x and you rewrite it as log base e of x. Then we do e to the 6th power equals x. And e to the 6th power, again in your 73, if you have a TI 73, you do math, log, go down to the 4th one, which is e to the 6th power, and it's 403.4. All right, a couple more here. 17, the best type of problem, ln 4x minus 2 equals ln 8x. Ln on both sides means it cancels. So you just have 4x minus 2 equals 8x. You subtract 4x from both sides. You get negative 2 equals 4x. You divide by 4 on both sides. X equals negative 1/2. Number 18, this is an inverse problem. So the first thing I do is write 4 to the y power equals x plus 3. The inverse means I'm going to trade the x and the y. So my new answer is going to be 4 to the x equals y plus 3. That's not a bad answer, but y really should be by itself. So if we subtract 3, we get 4 to the x minus 3 equals y. That's the official inverse. One more problem here that I'm going to work. I'll leave the graphing ones for you guys to do on your own. 6 to the y power equals x minus 3. Take the y and the x, switch them. 6 to the x equals y minus 3. That doesn't look right. Let's do that again. Add 3 to both sides to get y by itself. 6 to the x plus 3 equals y is my inverse. That's all of the review. You're ready for your test. And so if you have any questions, come see me in class.